So we've looked at multiplying a monomial times a trinomial. We've looked at multiplying two binomials. Now the last part here is to be able to multiply a binomial and a trinomial. Okay, so what are we going to learn? We're going to learn how to multiply polynomials, why multiplying is an inverse of factoring when it comes to polynomials, and factoring helps us find x-intercepts. And that's kind of what we're leading to, is this topic of factoring. How do we know if we have accomplished today's what? Well, given a binomial and a trinomial, we can find their product. And remember, product means multiply in math, the answer to a multiplication problem. All right, so a binomial and a trinomial, well, that's what this is. This is a binomial, 1, 2, multiplied by a 1, 2, 3 trinomial. So remember, this is a linear binomial. This is a quadratic trinomial. So a binomial and a trinomial. Okay, so let's do the work. So just like before, what we need to do is we need to multiply both of these terms to all three of these terms. So I'm going to distribute 3 times and then distribute 3 times. Okay? So I'm going to distribute 3x first. So that would be 3x times x squared, which, I mean, if you know what it is, you don't really need to show this. And then it's going to be 3x times 2x. And remember, we always want some sign in between our terms. This is a term, this is a term, and then we have 3x times negative 1, and I went ahead and put the plus here. So we'll let the product determine whether this stays positive or goes to negative. Okay, so far I've distributed 3x into these 3 terms. Now I need to do the same thing with 4. Okay, so I'm going to distribute that 4. So I've got 4 times x squared. I've got 4 times 2x. And I've got 4 times negative 1. Okay, so look, I have 1, 2, 3, 4, 5, 6 terms because it's 2 times 3, which gives me 6. Now, I will end up simplifying, and we will be able to collect like terms. Okay, so we've got 3x cubed, because you keep the base and add the exponents. 3 times 2 is 6, and 1 plus 1 is 2, so you get a 6x squared. Negative 1 times 3 is negative 3x. And then 4 times x squared is just 4x squared. 4 times 2 is 8 with an x is 8x. And then 4 times negative 1 is negative 4. Okay, so let's look and see other like terms. Well, it looks like there's a x squared there and an x squared there. They can go together. There's a negative 3x and a positive 8x, and those can go together. Okay, so 3x cubed has nothing to combine with. I'm going to take this one and add them together. I'm going to take this one and add them together. Remember, when you're adding, you don't do anything to the exponents. So it's just, you have 8 x's, you're taking away 3 of those x's, that gives you 5 x's. And then here I have a negative 4 here at the end, nothing to combine with. Okay, notice how it's in standard form. I got a third power, a second power, a first power, and my constant. So it is in standard form. So I end up with a cubic polynomial. Because remember, if there's more than 3, we just call it the umbrella of a polynomial. It's a cubic because it's a third power. Okay, let's look at example 2. So we're going to do the same thing here. We'll start with this 2x, and we'll distribute. Okay, and again, if you know what that is, you can just write down what it is there. if you know that 2x times negative 3x squared is actually negative 6x cubed, then you can just write it. If not, you can just show your steps. So notice how I have, again, I have a sign in between each term. I got this plus. So I'm going to do 2x times negative 7. Now I'm going to distribute the negative 5. So I'm going to do negative 5 times negative 3x squared. Since this is a minus, I went ahead and put the minus there. Okay, negative 5 times 4x, and then negative 5 times negative 7. And again, we're going to let the outcome of the product determine if this stays negative or becomes a positive. Okay, so here we know it's going to become a negative. This will stay positive, but it's going to be x squared. This will turn into a negative. This will become a positive. This will become a negative. And then that becomes a positive. Okay? And we need to collect like terms. So again, the x cubed doesn't have anything to combine with. We've got 8x squareds, and we're adding 15x squareds. That gives us a total of 23x squareds. Notice how I do not change the exponent when we're adding. And I have negative 14x's and negative 20x's, which gives me a total of negative 34x's. And then I get a plus 35 at the end. Okay, yeah, we have a couple big numbers, but if you don't know what negative 14 minus 20 is, put it in Desmos. Just put in negative 14 minus 20. And then just know there's an x attached. So that's why you get negative 34x. And again, we have a cubic. 4 terms becomes a polynomial. Cubic polynomial. Okay, so here's a U-try. So go ahead and pause the video and try it to see if you get the correct answer. So I'm going to distribute the x. Distribute it there to the 4x, and then distribute it there to the minus 2. Next step is to distribute the 3. So first to the x squared, then to the 4x, then to the minus 2. So when I simplify here, I end up with x cubed. This becomes a positive 4x squared. This becomes a negative 2x. This becomes a positive 3x squared. This becomes a positive 12x. And this becomes a negative 6. Okay, and then we have 1, 2, 3, 4, 5, 6 terms, which will simplify to 4 terms because we are able to collect or combine like terms. So x cubes, no other x cubes. X squareds, yep, there's another one right here, so we can combine these two. 4 plus 3 is 7. So we have 7, positive 7x squared. We got an x and an x right here. So you have 12 x's. You take away 2 of those x's. That becomes 10x. And then we have a minus 6 there at the end. So again, we have a 1, 2, 3, 4 terms, which is a polynomial. And it's to the 3rd power. So it's a cubic polynomial. Okay, so hopefully you guys got it right, and we're making it easy here. So homework is this one problem. So go ahead and do that problem. And if it's on formative, you know if you're getting it right or wrong because it will give you the green dot. All right.